Welcome to the peaceful space of sleep-friendly science, where we journey to the silent, dark abyss to witness a truly remarkable paradox: how a single, final breath can give rise to an entire universe of life. So, close your eyes if you feel comfortable. Imagine the endless blue fading to black as we descend into the quiet depths. Here, on the ocean floor, a magnificent story of creation is about to unfold from the most unexpected of sources, nurturing a community for 100 years. Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Great Descent. Before the fall, there is the life. Imagine, if you will, a creature of impossible scale, a living island adrift in the vast, sun-drenched expanse of the upper ocean. Picture a great blue whale, or perhaps a fin whale, a leviathan gliding through the sapphire world. For nearly a century, this has been its kingdom. Its skin is a cartographer's dream, a mosaic of scars and patterns telling stories of long journeys, of encounters with kin, and the casual brush of barnacles who have made its body their home for the ride. Its life is a slow, rhythmic dance. A great inhalation at the surface, a plume of breath misting into the sea air like a temporary ghost, and then the deep, graceful dive. It descends into the cool, pressurized blue, its immense body moving with an economy and elegance that defies its size. Its heart, as large as a small car, beats a slow, ponderous rhythmic deep drum marking the tempo of the ocean itself. This is a creature that has felt the warmth of the equatorial sun and the chilling kiss of polar ice. It has navigated by the silent pull of the Earth's magnetic fields, a living compass on a planetary pilgrimage. Its world is one of sound. It is a singer of ancient, resonant songs, melodies that travel for hundreds, even thousands of miles through the water. These are not just calls, they are a language. They are stories of krill blooms, of shifting currents, of memory itself, woven into the very fabric of the sea. In the deep, resonant chambers of its body, it carries the history of the ocean's seasons. It is a great, living library, its mind and body a repository of 100 years of sunlight, 100 years of plankton blooms, 100 years of salt and song. Within its body, a universe of potential energy is stored. Layers of blubber, thick and rich, are more than just insulation. They are a legacy of countless krill feasts, a patient accumulation of the sun's energy, transformed from the smallest of life forms into the substance of the largest. This whale is a mountain of life, a concentration of cosmic energy made manifest in flesh and bone. But all songs must eventually fade, and all great journeys find their end. There is no sudden violence, no dramatic chase. For our whale, the end comes as life began. Quietly. It is a gentle slowing. The immense heart, which has beaten billions of times, begins to beat a little more slowly, a little more softly. The great flukes, which have propelled it across oceans, give one last, weak push. There is a final, quiet sigh, a release of air not at the surface, but deep within the blue. Its long consciousness, a universe of oceanic memory, dissolves back into the quiet hum of existence. It is not an end, but a profound transformation, a handing over. And now the great descent begins. The body, now a silent vessel, starts its slow, final journey downwards. It leaves the sunlit world behind, the epipelagic zone where light dances and photosynthesis reigns. For a time, it is still visible, a vast, dark shape sinking through shafts of turquoise and azure light. It is a sight of somber, breathtaking majesty, a cathedral in freefall. As it sinks, the pressure begins to build, a gentle, then firm, then immense embrace from the ocean. The water cools dramatically. The familiar blues fade to a deep, twilight violet. It is passing through the mesopelagic zone, the world of perpetual twilight. Here, life flickers with its own internal light. Strange, Gelatinous creatures and fish with telescopic eyes drift past the sinking giant, their brief, bioluminescent flashes like fleeting constellations in a private cosmos. They are the first to witness this monumental gift to the deep. The descent continues, slower now, but ever downward. 1,000 meters. 2,000. It enters the bathyal zone, the midnight world. Here, there is no sun. There has never been sun. There is only absolute blackness, a cold that seeps into the very marrow, and a pressure that would crush a submarine like a tin can. The whale's form, built for the pressures of the upper ocean, begins to yield. Its ribcage groans and gives way, the internal cavities collapsing under the colossal weight of the water above. It is being remade, sculpted by the physics of the abyss. The silence here is unlike any silence known on land. It is not an absence of sound, but a presence. A heavy, resonant quiet that you can almost feel against your skin. The only sound is the faint, whispery rush of water over the whale's immense, still form as it continues its pilgrimage into the dark. It falls past unseen landscapes, the sheer cliffs of undersea canyons, the volcanic cones of sleeping seamounts. It is a ghost ship sailing through an unseen, alien geography. 3,000 meters. 4,000. It has reached the abyssal plain, the abyssopelagic zone. The pressure is now over 400 times that at the surface. The temperature hovers just above freezing. This is one of the most stable, unchanging environments on planet Earth. A world of fine, soft sediment, the accumulated dust of millennia, the microscopic shells of dead plankton, cosmic dust, and volcanic ash that have all made this same slow journey. It is a soft, dark desert waiting. And then, after a journey that may have lasted for hours or even days, it arrives. There is no violent crash. It is a soft, world-altering landing. A deep, resonant thud that is more felt than heard, a pressure wave that radiates outwards for meters through the silty floor. The immense weight of the whale, this gift of organic matter, settles into the ooze. A cloud of ancient sediment billows up, a brown ghost in the utter blackness, before slowly, gently, settling back down, blanketing the edges of the great, still form. For a moment, there is only stillness, the profound, absolute stillness of the deep sea. The whale lies on the abyssal plain, a mountain of potential in a vast, dark desert. It is an anomaly of impossible richness in a world defined by scarcity. The last echo of its impact fades. The water clears. The great vessel has reached its final harbor. Its century-long song is over. But a new symphony, a silent, chemical, and biological opera, is about to begin. The scent, the faintest chemical whisper of this enormous arrival, begins to travel on the slow, cold currents. And in the dark, something stirs. Section 2. The banquet begins. The whisper spreads. It is not a sound, but a chemical rumor carried on the glacial currents of the abyss. A molecule of fat, an amino acid, a ghost of the whale's lifeblood detaches and begins its slow drift. To the sparse and scattered inhabitants of the abyssal plain, this scent is an explosion. It is a trumpet blast in a silent library, a lighthouse beam in an endless night. In a world where a single fishfall is a notable event, the arrival of a whale is a geological and biological cataclysm of fortune. And so they come. The first to arrive are the true rulers of the deep, the patient, ancient predators. From kilometers away, a Pacific sleeper shark, or perhaps its Arctic cousin, the Greenland shark, catches the scent. This creature is less a fish and more a living piece of geologic time. Its movements are impossibly slow, a study in energy conservation. Its eyes, often colonized by luminous parasites, are clouded and nearly blind, but it does not need to see. Its entire body is an antenna for the faintest signals of life, or in this case, death. It follows the chemical trail not with speed, but with an unerring, implacable certainty. It is a living torpedo of patience, a 6-meter-long phantom of gray skin and prehistoric instinct. When it arrives at the whale fall, there is no frenzy. It approaches the colossal form with the same slow grace it uses to traverse the empty plains. It bumps against the mountain of flesh, its blunt snout exploring the new geography. Then, its jaw, a strange and terrible apparatus, unhinges. It bites down, sinking its rows of sharp upper teeth into the blubber to anchor itself. Then, with a slow, powerful rotation of its entire body, it carves out a perfect, round plug of flesh, a motion like an ice cream scoop cutting into frozen cream. It swallows the basketball-sized piece whole and drifts away slightly, digesting its prize before returning to repeat the process. It is a methodical, efficient, and strangely clean form of feeding. More sharks arrive, materializing from the oppressive dark like gray ghosts drawn to a spectral campfire. They circle the carcass in a slow, hypnotic ballet, taking turns to carve their share from the great gift. But they're not alone. Something else is stirring, something far more primal. From burrows in the surrounding mud, they emerge. The hagfish. These are creatures that defy simple categorization. They are not quite fish. They are living fossils, jawless and eel-like, who have remained almost unchanged for over 300 million years. They are the ghoulishly elegant undertakers of the abyss. They arrive not as individuals, but as a tide. A flowing, writhing river of pinkish-gray bodies converges on the whale. They do not bite or tear. Instead, they press their rasping, tooth-lined mouths against the skin and enter the body through any available opening the mouth, the wounds left by the sharks, the collapsed cavities of the chest. They flow inside the whale, becoming a living infestation, a network of arteries filled with a new, hungry purpose. Once inside, they begin to feed from within. They secrete powerful enzymes that dissolve the muscle and organ tissue into a slurry, which they then absorb. And if they are threatened, they exhibit their most famous trait, the slime. From glands along their bodies, they can exude a protein that, upon contact with seawater, instantly expands into a vast, gelatinous cloud of mucus, choking any would-be predator. They are slippery, elusive, and single-minded. Watch them as they work. A hagfish, having gorged itself deep within the carcass, needs leverage to pull away a piece of tougher tissue. So it ties its own supple body into a knot, starting at the tail. The knot slides up its length until it presses against the whale's flesh, providing an anchor. With a powerful pull against its own knotted form, it tears the food free. It is a trick of biomechanical genius, a solution born of an eternity in the dark. They become so numerous that parts of the whale seem to be dissolving into a moving mass of these living knots. Now the smaller guests arrive at the banquet. The floor around the whale begins to seethe with motion. An armored tide of crabs, from small, scurrying lithidids to larger, spidery king crabs, marches in from the surrounding plains. They are the legionaries of the feast, clipping and snipping with their claws, meticulously picking away at the flesh exposed by the larger scavengers. Their clicking and scuttling would create a cacophony in the air, but here in the crushing silence, their frantic activity is a visual roar. And among them, a blizzard of smaller life. Amphipods, like tiny, hyperactive shrimp, swarm in clouds so thick they obscure the whale's form. They are the piranhas of the deep-sea insect world, each one a tiny, voracious mouth. They settle onto the carcass in a living, shimmering blanket, stripping away tissue molecule by molecule. They clean the bones with a jeweler's precision, their sheer numbers accomplishing what their small size cannot. The scene is one of shocking, silent, chaotic vitality. It is a temporary city, built upon a foundation of death, and it is governed by one simple rule: eat. There is no day or night here to mark the passage of time, but if there were, the feast would rage on for weeks, for months, without ceasing. The water, once clear, is now thick with a soup of organic debris, a constant snow of sustenance for the smaller creatures waiting on the periphery. This is the mobile scavenger stage, a period of explosive, frantic consumption. The whale, which took a century to grow, is being unmade in a fraction of that time. The sharks carve away the blubber, The hagfish liquefy the organs from within, the crabs tear at the muscle, and the amphipods polish the leftovers. They are collectively returning the whale's stored sunlight back into the deep-sea food web with breathtaking speed. It is a process of deconstruction that is, in its own way, a form of creation. An entire generation of deep-sea life will be born and will thrive on this single, monumental event. As the months pass, the scene changes. The great mountain of flesh and blubber has been worn down. The once sleek contours of the Leviathan are gone, replaced by a jagged landscape of exposed bone. The sharks, their bellies full and the easiest meals gone, begin to depart, melting back into the darkness from which they came. The rivers of hagfish recede, their work inside the great vessel largely complete. The frantic energy of the banquet begins to subside. The whale is no longer a body. It is a skeleton, a vast, white architecture laid bare on the abyssal floor. Its ribcage curves upwards like the arches of a ruined cathedral. The immense jawbones lie ajar like fallen pillars. The banquet of soft tissue is over. But for the community of the whale fall, the story is only just beginning. The departure of the first wave of guests simply makes room for the next. The focus of life now shifts from the fleeting flesh to the enduring bone and to the very ground, now rich and saturated, upon which it rests. A new chapter is about to be written by much smaller and, in many ways, much stranger authors. Section 3. The colonists arrive. The great devourers have moved on. The sleeper sharks have vanished back into their patient, wandering existence. The tide of hagfish has ebbed, leaving behind a hollowed-out monument. The frantic, clicking chaos of the crab legions has quieted. What remains is no longer a feast in the conventional sense, but something more subtle, more pervasive. The whale's influence has not disappeared. It has simply changed form. It has seeped into the very world around it. Imagine the floor of the abyss. It is a desert of fine, silted clay, a landscape of profound nutritional poverty. For millennia, the only sustenance here has been a slow, gentle rain of marine snow, the microscopic shells, fecal pellets, and organic detritus that drift down from the vibrant world of light, thousands of meters above. Life here is slow, small, and patient, adapted to a state of near starvation. But now, around the great skeleton, the desert has been transformed into an oasis. For months, the frenzy of the scavengers has rained down a blizzard of organic material. Tiny fragments of flesh, droplets of oil, and the waste products of the feasting multitudes have saturated the sediment, enriching it beyond measure. The mud itself is now a battery of life, charged with a sudden, shocking influx of energy. The chemical signature of the whale fall has become the chemical signature of the seafloor for tens of meters in every direction. And now the colonists arrive. They are not the swift, mobile scavengers of the first wave, but the patient homesteaders of the deep. They are the enrichment opportunists. From the surrounding mud, they begin to emerge and to multiply, their populations exploding in response to this sudden bounty. These are the polychaetes, the bristle worms of the deep sea. They are a fantastically diverse group, and here they find their paradise. Species like the small, hardy dorvalids and the delicate ceratulids begin to tunnel through the enriched sediment. If you could see them, the surface of the mud would appear to be alive with a network of tiny, questing tentacles and brilliantly colored gills, filtering the water and sifting the soil for every last molecule of nutrition. They are nature's plowmen. Their constant burrowing and feeding turns over the sediment, mixing the organic matter deeper into the mud and aerating the soil, a process known as bioturbation. They are not just feeding on the whale's legacy, they are actively cultivating it, transforming the soil into a habitable environment for others. They are like the earthworms of a new, dark garden, preparing the ground for what is to come. Among them are other, stranger worms. Some, belonging to the family Chrysopetalidae, are known as golden scaleworms. They crawl across the mud, their backs covered in iridescent, golden bristles that shimmer even in the faintest residual light from a passing submersible. They are living jewels crawling through a graveyard, a testament to the unexpected beauty that can arise in the most desolate of places. And as the worms flourish, so do their predators. The smaller crabs that remained after the main banquet now find a new, sustainable source of food. They patrol the enriched zone, picking off the unwary worms. Small, snail-like gastropods carve slow, deliberate paths through the mud, grazing on the films of bacteria that have begun to bloom on the nutrient-rich surfaces. Look closer at the sediment. It is teeming with a hidden universe of life. Tiny crustaceans, like the comma-shaped cumatians and the seed-like ostracods, navigate the spaces between grains of sand, their populations booming in this temporary land of plenty. They are the microscopic grazers of this new ecosystem, feeding on bacteria and organic detritus. For them, the enriched sediment around the whale is not just an oasis. It is an entire continent, a world of opportunity that will fuel their communities for years. This is the enrichment opportunist stage, a critical bridge between the explosive chaos of the first feast and the slow, simmering ecosystem yet to come. It is a period of consolidation. The energy of the whale is being transferred from the large, mobile scavengers down into the very foundation of the food web, the soil itself, and the small, often microscopic, creatures that inhabit it. This community of worms and small crustaceans can last for several years. Their lives are still governed by the fading echo of the whale's impact. As they live and die, they continue to cycle the nutrients through the sediment. The ground itself becomes a living entity, a slow-burning fire of biological activity. The energy is not being consumed as quickly as before, but it is being integrated, woven into the fabric of the local environment in a more permanent way. Imagine the scene now, perhaps 2 years after the whale's arrival. The frantic rush is long gone. A quiet sense of industry has taken its place. The great, white skeleton lies picked clean, a stark piece of architecture against the dark silt. The mud around it is no longer a uniform brown but a mottled patchwork of different textures and colors, evidence of the intense biological activity within. If you were to take a coarse sample of this mud, you would find it writhing with a density of life 1,000 times greater than the mud just 100 meters away. This stage is essential because it anchors the whale's gift. It prevents all the energy from being carted away by the fast-moving sharks and crabs. The worms and crustaceans act as a living capacitor, holding the energy in place, transforming it from a fleeting resource into a long-term, stable foundation. They are the pioneers, the first settlers who tamed the wild frontier of the whale fall, making it ready for the even stranger and more specialized life that will define the skeleton's true, long-term legacy. The whale is no longer just a source of food. It has become a place, a destination. Its chemical halo in the sediment has established a new geography of have and have not on the abyssal plain. And while this drama plays out in the mud, the skeleton itself, that great white cathedral, has been patiently waiting. It has served as a landmark, an obstacle, and a perch. But now it is about to become something more. It is about to become a world in its own right. The next wave of colonists will not settle the land around the whale, but the whale itself. Section 4. A Cathedral of Bone. The frenzy in the surrounding soil begins to quieten. The great bloom of worms and crustaceans, having consumed the most accessible nutrients in the sediment, starts to wane. Their populations shrink back to a more sustainable level, leaving the ground forever changed, but no longer the bustling metropolis it once was. The focus of our story now lifts from the mud and settles upon the great, silent structure that has presided over the entire affair, the skeleton itself. For years, it has been an architecture. Now it becomes an anchor. Imagine the abyssal plain. It is a world largely without features. A vast, soft, and monotonous expanse of silt. For an organism that needs a hard surface to attach to, a place to cling, to grow, to gain a foothold in the gentle but persistent currents, it is a frustrating desert of softness. Creatures like sea anemones, barnacles, and corals, which thrive on rocky outcrops and seamounts, are homeless here. The rare, Small rock that has tumbled down an undersea slope or been dropped by a melting iceberg is a precious piece of real estate, fiercely contested. But the whale skeleton, is a mountain range. It is an entire archipelago of hardness in an ocean of soft mud. The vertebral column is a long, curving ridge. The skull, with its vast, cavernous openings, is a complex of caves and overhangs. And the ribcage, arching upwards from the silt, is a magnificent ivory forest. It is a gift not of food, but of substrate, of place, of belonging. And so, the reef dwellers begin to colonize. The currents of the deep carry with them the microscopic larvae of countless species, adrift on a journey of chance. For most, this journey ends in the soft ooze, where they cannot settle and soon perish. But for the lucky few that drift into the vicinity of the whale fall, their journey ends in salvation. They bump against a hard, clean surface, the smooth, curved bone of a rib, the rough texture of a vertebra. And here they can attach. Here they can begin to grow. Slowly, tentatively, the bones begin to acquire a living fuzz. Small, delicate sea anemones, looking like pale, ghostly flowers, open their stinging tentacles to the dark water, hoping to catch a passing particle of food. They are the first blossoms in this bone garden. Their cousins, the zoanthids, form dense, interconnected mats, blanketing the surfaces of the flatter bones like a living, golden-brown carpet. Filter-feeding barnacles, who spent their lives riding upon the living whale's skin, now find a new, permanent home on its remains. Their larval forms settle and build their conical, white fortresses, extending their feathery cirri into the water to comb for sustenance. They add their own texture and architecture to the growing complexity of the reef. Delicate, branching gorgonians, or sea fans, take root. They look like skeletal trees growing upon a skeletal giant. Their growth is agonizingly slow in this cold, nutrient-poor water, perhaps only a few millimeters a year. But over decades, they will grow into intricate, beautiful fans, orienting themselves perfectly to the prevailing current to maximize their chances of capturing food. They are the slow, patient sentinels of this new community, their fragile branches providing yet another layer of habitat for even smaller creatures. The skeleton is no longer just bone. It is becoming a living reef, a true ecosystem. Its complexity snowballs. The presence of the first colonists creates new nooks and crannies, new surfaces, new microhabitats that attract others. Small, scavenging crabs, which once picked at the flesh, now crawl through the growing forest of anemones and sea fans, seeking shelter and preying on the smaller inhabitants. Brittle stars, with their long, spindly arms, wrap themselves around the bones and the stalks of the gorgonians, waving their arms in the water to trap passing particles. The very structure of the skeleton begins to alter the local environment in subtle ways. The towering ribcage and the broad skull create a baffle against the slow, deep currents. This creates eddies and areas of calmer water on the leeward side of the bones. This current shadow is a precious refuge. Here, weaker swimmers can exist, and finer particles of organic matter, the last remnants of the whale fall and the ever-present marine snow, can settle out and accumulate. These little pockets of calm and plenty become hotspots of activity. Look inside the great cavern of the skull. The eye sockets, once home to the whale's deep vision, are now hollows providing perfect shelter. A deep-sea octopus, a creature of soft body and high intelligence, might take up residence here. It can flow into the tightest of spaces, using the complex architecture of the skull as an impregnable fortress from which it can launch hunting forays for unsuspecting crabs. The transformation is profound. The whale, which was a single, monolithic organism in life, has become a diverse and complex city in death. It is a high-rise apartment building on the abyssal plain. Each bone is a neighborhood, each crack and fissure a home. The community it supports is no longer dependent on the original burst of energy from the flesh, but on the steady, sparse rain of marine snow from above, just like any other deep-sea reef. The skeleton has allowed a typical hard substrate community to exist where it otherwise never could. But this stage, as important as it is still just a surface-level story. The colonists are living on the bones, but they are not consuming them. The true, deep energy of the whale, the immense store of lipids and proteins locked within the bones themselves, remains untouched. The skeleton has provided a home, but it has not yet given up its greatest secret, its most potent gift. Deep within the marrow, in the microscopic, porous spaces of the bone matrix, another process has been quietly, invisibly beginning. It is a chemical transformation, driven by organisms that do not need light, do not need to hunt, and do not breathe oxygen. They are consuming the very essence of the skeleton from the inside out, and in doing so, they are preparing the ground for the third and most alien act of this deep-sea play. The Cathedral of Bone is not just a foundation. It is a pantry, and the creatures with the key to this pantry are about to emerge, changing everything once again. Section 5. The Hidden Fires Within. The surface of the Bone Cathedral is now a bustling, if slow-moving, city. Anemones bloom, crabs scuttle, and sea fans wave like spectral trees in the imperceptible currents. This is the visible world of the whale fall, a community living on the architecture of the skeleton. But the true heart of the next chapter of this story beats not on the surface, but deep within the bone itself. To understand it, we must leave the world of familiar biology off hunting and grazing and filtering and enter the alien realm of pure chemistry. A whale's skeleton is not like the dry, inert bones you might find on land. A significant portion of its mass, up to 60% by weight, is not mineral, but organic material. And chief among this material are lipids, fats. The whale's life of feasting on krill has packed its very bones with a tremendous reserve of energy-rich oil. A single large whale skeleton can contain several tons of this precious, greasy fuel. On the energy-starved abyssal plain, this is a treasure chest of unimaginable wealth. But this treasure is locked away. The lipids are trapped deep inside the dense, complex matrix of the bone. For the crabs and the anemones on the surface, this energy is completely inaccessible. They lack the biological tools to break down the bone and extract the fats. Unlocking this treasure requires a key, and that key belongs to a group of organisms that are the true masters of planetary chemistry, bacteria. As soon as the skeleton was picked clean by the first wave of scavengers, a new, invisible colonization began. Sulfate-reducing bacteria, which are naturally present in the deep-sea sediment and water, began to settle on and permeate the porous bones. These are anaerobic organisms, meaning they thrive in environments without oxygen. The dense, oily core of a whale bone is just such a place. Once inside the labyrinthine network of the bone's interior, they begin their slow, methodical work. They are not eating in the way an animal does. They are performing a chemical miracle. They use the rich lipids locked in the bone as their energy source, their electron donor. But for this chemical reaction to work, they need something to breathe. Since there is no oxygen, they use sulfate, SO4 superscript 2, a common ion dissolved in seawater, as their electron acceptor. Imagine it as a kind of slow-motion chemical fire. A normal fire uses organic fuel, like wood, and an oxidizer, oxygen from the air, to release energy as heat and light. These bacteria are using an organic fuel, the whale lipids, and a different kind of oxidizer, sulfate from the seawater, to release energy for their own life processes. The byproduct of this breathing of sulfate is a substance of immense biological importance, hydrogen sulfide, H2S. This is the gas that gives rotten eggs their characteristic, pungent smell. To us, and to most oxygen-breathing life, hydrogen sulfide is a potent poison. It shuts down our cellular respiration, the very process that gives us life. But in the deep sea, this poison is a source of creation. Slowly, steadily, over years, the bacteria inside the whale bones break down the lipids and exhale this toxic sulfide. The gas, dissolved in the water, begins to seep out of the porous bones. The entire skeleton is now like a series of slow-release chemical vents. It is no longer just an inert structure. It is an active chemical reactor, broadcasting a powerful, poisonous signal into the surrounding water. This is the beginning of the sulfophilic stage, which means sulfur-loving. And it is the longest and most stable phase of the whale fall's existence. But the process doesn't stop there. The hydrogen sulfide now becomes the fuel for a second, distinct group of bacteria. These are the sulfide oxidizing bacteria, also known as chemosynthetic bacteria. They swarm on the surface of the bones, forming thick, white, filamentous mats that look like a soft, pale fur growing on the skeleton. These bacteria are true alchemists. They perform a process called chemosynthesis. While plants on the surface use photosynthesis using the energy of sunlight to turn carbon dioxide into organic matter, these bacteria use chemosynthesis. They take the chemical energy stored in the bonds of the toxic hydrogen sulfide and use it to turn carbon dioxide dissolved in the seawater into sugars and other organic molecules. They are creating life not from light, but from a chemical poison seeping from a dead giant's bones. They are the primary producers of this new ecosystem. Just as grass and phytoplankton form the base of the food webs on land and in the sunlit ocean, these chemosynthetic bacterial mats are the foundation of the whale fall community. They are a self-sustaining garden growing in absolute darkness, fueled by the hidden fires within the bones. This two-step process is a masterpiece of microbial synergy. The first group of bacteria, deep inside the bone, consumes the lipids and produces the sulfide. The second group, on the surface of the bone, consumes the sulfide and produces organic matter. It is a perfectly balanced, self-regulating engine that can run for decades. As long as there are lipids in the bones and sulfate in the water, this chemical garden will continue to bloom. The whale skeleton has undergone its most profound transformation yet. It has ceased to be merely a physical object. It has become a metabolic engine. It is now, for all intents and purposes, a miniature hydrothermal vent system. The principles are the same. A geochemical process releases a reduced chemical, like sulfide, which is then used by chemosynthetic organisms to create a vibrant ecosystem in the absence of sunlight. The great beast has become a chemical beacon. The scent it now gives off is no longer the smell of decaying flesh, but the sharp, metallic tang of sulfide. And this new scent is a call. A dinner bell for a whole new cast of characters, creatures so strange and so specialized that they can only exist in these unique, toxic oases on the deep sea floor. They have been waiting for this signal. They are the sulfur lovers, and they are about to arrive and build their city upon the foundation of this dark, chemical garden. Section 6. A garden in the dark. The skeleton is no longer silent. It hums with a quiet, chemical energy. The invisible work of the bacteria within has transformed the great boneyard into a chemical oasis, a place where the toxic breath of one microbial kingdom becomes the lifeblood of another. The thick, white mats of sulfide-oxidizing bacteria now coat the bones, a living fleece that is the first course in a new and extraordinary banquet. The air of the watery is thick with the promise of sulfide, and this promise draws in a new community, one that thrives not just near the whale, but in symbiosis with its chemical output. This is the era of the chemosymbionts. From the surrounding water, microscopic larvae of specialized clams and mussels begin to settle. These are not the familiar bivalves of the sunlit shallows. They belong to families like the Vesicomyidae and the Mytillidae, the same groups of animals that cluster around the gushing, superheated water of hydrothermal vents. Their presence here, on a cold, dead whale, is a testament to the unifying power of chemosynthesis. A tiny clam, no bigger than a grain of sand, settles onto the bacterial mat covering a rib bone. It begins to grow, but it does not feed in a conventional way. It has a reduced gut, sometimes no gut at all. It has no need to filter food from the water. Its life is a partnership. Within its specialized gill tissues, it cultivates a vast, internal garden of those same chemosynthetic bacteria. This is a covenant between two life forms. The clam, nestled against the bone, acts as a living conduit. It draws in the sulfide-rich water seeping from the skeleton and the oxygen from the surrounding seawater. It pumps these two essential ingredients to the bacteria living safely inside its gills. The bacteria, in their protected, internal world, perform their chemical magic. They oxidize the sulfide, creating energy, and use that energy to produce sugars and other organic compounds. These nutrients are then directly absorbed by the clam. The clam provides the house and the raw materials. The bacteria provide the food. It is a perfect, self-contained ecosystem within a single animal. The clam is a living fuel cell, powered by the whale's ghost. Vast beds of these clams and mussels begin to form, covering the whale skeleton. Their white and yellowish shells add a new layer of texture and complexity to the reef. They grow shell to shell, forming dense clumps that can persist for decades, a living armor over the bones. Their growth is slow but steady, fueled by the relentless, invisible chemistry within. They are the farmers of this dark garden, tending their internal crops. And among them, another, even more iconic chemosynthetic specialist begins to grow. It starts as a tiny, settling larva, but it will become one of the signature life forms of the whale fall. The tube worm. Species like Lamellobrachia or Escarpia take root. They do not have a mouth. They do not have a gut. They do not have an anus. They are, in essence, a closed bag. What they do have is a bright red, feathery plume that extends from the top of their protective, chitinous tube. This plume is not for breathing in the conventional sense. It is for gathering the ingredients of life. It is a highly complex organ, rich with a special kind of hemoglobin that is exceptionally good at binding to both oxygen and sulfide simultaneously, a chemical trick that would poison most other animals. The worm absorbs these chemicals from the water and transports them down its long body to an internal organ called the trophosome, which means feeding body. The trophosome is packed with billions of symbiotic chemosynthetic bacteria. Just as in the clams, these bacteria are the worm's power source. They're fed a steady diet of sulfide and oxygen, and in return, they produce all the nutrition the worm needs to live and grow. The worm's tube, which can eventually grow to be over 1 meter long, is anchored to the whale bone. It grows slowly, patiently, its red plumes swaying gently in the dark water, a splash of vibrant color in a monochromatic world. They grow in dense thickets, especially around the oil-rich vertebrae and the skull. They look like a strange, alien flower bed, a silent, crimson garden planted in a bone field. Their presence further transforms the whale fall, their tubes creating yet another layer of complex, three-dimensional habitat. The community is becoming richer, more interwoven. The shells of the living clams and mussels, and the tubes of the worms, become new surfaces for other life to settle upon. The pale anemones and barnacles from the earlier reef stage now grow upon the shells of the chemosynthetic community. Snails, specialized to this environment, crawl across the clam beds, their radulas modified to scrape away at the bacterial mats or even to prey upon the soft tissues of the bivalves. Small, white, blind crabs, relatives of the yeti crabs found at hydrothermal vents, scuttle through the tube worm thickets. They use comb-like structures on their claws to harvest the bacterial filaments, combing them off the bone surfaces and the worm's tubes and bringing the bounty to their mouths. They are the nimble shepherds of the bacterial flocks. The ecosystem is now in its prime. It is a multi-layered, self-sustaining world. At its heart is the whale bone, the slow-release battery. Leaking from this battery is the sulfide, the chemical fuel. Harnessing this fuel are the bacterial mats, the primary producers. Living in direct partnership with the bacteria are the great clam beds and the tubeworm gardens. And living among and upon them all is a diverse community of grazers, predators, and scavengers. The whale is no longer a skeleton. It is a city-state, a bustling island of life with its own unique economy based on sulfur. It is a world that runs on a completely different set of rules from the sunlit world above. Here, life does not depend on the sun, but on the chemical legacy of a giant that once swam in it. The energy of 100 years of sunlight, stored in the whale's body, has been transformed, passed through scavengers, sunk into the mud, and then resurrected by bacteria to fuel a chemical garden that will now bloom in the eternal night for 50, 60, even 70 years. It is the whale's second life, a life of quiet, chemical brilliance, a slow and steady pulse of vitality in the crushing, silent dark. Section 7. The Bone-Eating Flowers. The city of bone and sulfur is thriving. The clam beds are established, and the crimson plumes of the tube worms sway in a silent, hypnotic rhythm. The ecosystem seems to have reached its mature, stable peak. It is a world built upon the foundation of the skeleton, powered by the chemical reactions within it. But there is one more secret to be revealed, one more group of colonists to arrive. And these are, perhaps, the strangest of all. They are the bone devourers, the true specialists. Look closely at the surface of the bones, in the spaces between the clam shells and the tube worm anchors. You might see what looks like a delicate, reddish, feathery plant. A small, root-like structure appears to be growing directly out of the hard bone itself, with a soft, flower-like plume branching out into the water. It looks like a tiny, alien moss, a splash of organic color on the pale calcium phosphate. But this is no plant. This is an animal, a worm of the genus Ostax. The name Ostax is Latin for bone-devouring, a fitting name for a creature that has perfected the art of eating a skeleton. They are more commonly and more poetically known as zombie worms. Let us follow the life of one of these incredible creatures. A microscopic, free-swimming larva is released into the water column. It is on a quest for a very specific home, a dead vertebrate's bone on the seafloor. For most larvae, this quest will fail. But this one is lucky. After drifting for an unknown amount of time, it senses the chemical signature of the whale fall. It settles onto a bare patch of a great rib bone. And here, something remarkable happens. The larva begins to transform. It does not grow a mouth. It does not grow a stomach. It develops a specialized organ that begins to secrete a powerful acid. This acid starts to dissolve the hard, mineral matrix of the whale bone, boring a hole directly into its surface. The worm is not scraping or gnawing. It is melting its way into the skeleton. Once inside, the worm's body develops into a bizarre and beautiful structure. It creates a branching, root-like system that spreads throughout the bone's porous interior. These roots, which are greenish in color, are not for anchoring. They are the worm's digestive and absorptive system. The roots are filled with symbiotic bacteria, but these are different from the chemosynthetic bacteria of the clams and tube worms. The bacteria inside the Ostax roots are specialists in breaking down complex organic molecules, specifically the collagen and lipids that are still locked within the bone matrix. The worm drills into the bone, and its internal bacterial partners digest the complex proteins and fats. The worm then absorbs the nutrients directly through its roots. It is, in effect, mining the skeleton. It has found a way to access the treasure chest of energy that even the sulfate-reducing bacteria couldn't fully exploit. The part of the worm that we can see, the delicate, reddish plume that extends out of the bone, is its breathing apparatus. These are the gills, absorbing precious oxygen from the seawater to fuel its own metabolism and that of its bacterial partners. It looks like a flower, but it is the respiratory organ of a creature whose body is hidden deep inside the bone, its green roots spreading like a fungal network, dissolving and consuming the very structure it lives in. The story of Ostax gets even stranger when we consider their method of reproduction. The feathery, flower-like creatures we see are all female. They are the miners, the ones who bore into the bone. But where are the males? The males are microscopic. When a male Ostax larva lands on a bone, it does not seek out the bone itself. It seeks out a female's tube. It then enters the tube and travels down to her body, where it lives as a parasite, a harem of tiny males living within the female's gelatinous tube. A single female can host dozens, even hundreds, of these dwarf males. Their sole purpose in life is to produce sperm to fertilize her eggs. They are stripped-down, simplified organisms, little more than reproductive factories, living entirely off the resources gathered by the female. The female, her roots deep in the nutrient-rich bone, her gills breathing in the dark water, and her harem of males safely stowed away, becomes an egg-producing machine. She releases vast quantities of fertilized eggs into the water, which develop into the next generation of free-swimming larvae, ready to seek out their own whale fall, or perhaps a stray sea turtle shell or a large fish skeleton. The zombie worms are the ultimate whale fall specialists. Their entire life cycle, their unique anatomy, their strange reproductive strategy is all perfectly adapted to the exploitation of a rare but incredibly rich resource. They are the cleanup crew that takes care of the very last, most difficult-to-access energy source. For decades, they coexist with the chemosynthetic community. The clams and tube worms thrive on the sulfide leaking from the bones, while the Ostax worms mine the lipids and proteins from within the bone matrix itself. They are two parallel ecosystems, two different ways of life happening on and in the same skeleton. But the work of the Ostax is a process of ultimate destruction. Unlike the clams, which merely use the skeleton as an anchor, the zombie worms are consuming it. Their acid-boring and root-spreading activities weaken the structural integrity of the bones. Over many, many years, the skeleton, which once seemed so permanent, begins to crumble. The bones become pitted and brittle. The great arches of the ribcage, hollowed out from within by countless generations of worms, begin to collapse under their own weight. The arrival of the Ostax marks the beginning of the end for the skeleton itself. They are the undertakers who will ensure that not a single joule of the whale's life energy goes to waste. They are beautiful, strange, and relentless. They are the final flourish of life, a garden of bone-eating flowers that blooms just before the lights of the city finally go out. The cathedral is being deconstructed, one acid-dissolved grain at a time, from the inside out. Section 8. The Fading of a Kingdom. For 50, 60, perhaps even 70 years, the whale fall has been a beacon of impossible life in the abyssal desert. It has been a raucous banquet hall, a fertile oasis, a living reef, a chemical engine, and a garden of bone-eating flowers. But no battery can last forever. The whale's legacy, as vast as it was, is finite. The long, slow twilight of the kingdom begins. The change is not sudden. There is no cataclysm, no dramatic event. It is a gentle, inexorable fading, like a fire running out of fuel. The first sign of this decline comes from deep within the bones. The twin engines that have powered the ecosystem for decades begin to falter. The sulfate-reducing bacteria, which have been tirelessly converting lipids into sulfide, find their food source dwindling. The richest, most accessible fats have all been consumed. The remaining organic material is locked away in more complex, harder-to-reach pockets of the bone matrix. Their metabolic rate slows, and as a result, the production of hydrogen sulfide, the lifeblood of the chemosynthetic community, begins to decrease. On the surface, the effects are profound. The thick, white bacterial mats, which once coated the bones like a layer of fresh snow, start to thin out and become patchy. The chemical fuel that sustained them is sputtering. For the community that depends on this foundation, it is the beginning of a famine. The great beds of chemosynthetic clams and mussels are the first to feel the strain. Their internal gardens of bacteria are no longer receiving the steady supply of sulfide needed to produce food. The bivalves can survive for a time, drawing on their own reserves, but the slow starvation is inevitable. Growth ceases. Reproduction becomes a luxury they can no longer afford. One by one, over the course of years, they perish. Their shells gape open, their soft tissues consumed by the ever-present small scavengers. The dense, living armor that once covered the skeleton begins to fall away, revealing the bone beneath once more. The tube worm thickets, those vibrant crimson gardens, also begin to wither. Their plumes, which once extended so proudly into the water, retract more and more often. The worms, dependent on the same failing sulfide supply, shrink within their tubes. Eventually, they too die, leaving behind their empty, chitinous husks of forest of hollow pillars in a dying city. At the same time, the Ostax worms are completing their own inexorable work. They have been mining the skeleton from within, their acid-laced roots dissolving the very structure of the bone. The skeleton, once a mighty cathedral, is becoming fragile and brittle. It is riddled with boreholes, like ancient wood eaten by termites. The great arch of a rib, weakened from within and no longer supported by the living buttress of a clam bed, finally gives way. It collapses with a slow, silent puff of sediment, shattering on the seafloor. Another follows, then another. The majestic architecture that defined the whale fall for a century is crumbling into dust and fragments. The skull, hollowed out and fragile, settles and cracks, its great caverns collapsing in on themselves. As the primary chemosynthetic community dies off, the secondary community that depended on it also disappears. The specialized crabs that combed the bacterial mats find their pastures barren. The snails that grazed on the clams find their prey gone. The entire, complex web of life that was built upon sulfur begins to unravel, thread by thread. The bustling city reverts to a ghost town. The scene is now one of serene decay. It is perhaps the 80th or 90th year since the whale's arrival. The landscape is a jumble of bone fragments and empty shells. The vibrant colors of the tube worm plumes and the pale yellows of the clam shells are gone. What is left is a palette of white and gray and the dark brown of the abyssal mud. Life has not vanished entirely, but it has changed dramatically. The community begins to resemble the one that existed before the chemosynthetic boom, the simple reef community. The hard surfaces of the bone fragments and the empty shells still provide a valuable substrate in the soft sediment world. Hardy, slow-growing filter feeders like sponges, sea anemones, and a few resilient gorgonians still cling to the wreckage. They were here before the sulfur lovers arrived, and they will remain long after they are gone. They are the old guard, adapted to the sparse, steady rain of marine snow, not the boom-and-bust economy of the whale fall. The specialist predators are long gone. The ecosystem's unique energy source has been extinguished. The whale fall is no longer a self-sustaining oasis. It is returning to what it was in the beginning, a physical structure, a ghost reef. The fading of the kingdom is a process of subtraction. The energy that was so powerfully concentrated in the whale's body has now been fully dispersed. It has fueled generations of sharks and hagfish, enriched the soil for worms and crustaceans, anchored a reef for anemones, powered a chemical garden for clams and tube worms, and been mined from within by zombie worms. The whale has given everything it had. Its century of accumulated sunlight has been spent, paid out to the deep. The process is one of profound, beautiful, and unsentimental recycling. The death of the whale fall ecosystem is not a tragedy. It is the fulfillment of a cycle. The energy has not been lost. It has been transformed into the flesh and shell and life of countless deep-sea creatures, nurturing a lineage of life in the most inhospitable place on Earth. The great giant's final gift has been fully unwrapped. What is left behind is no longer a source of life, but a monument to it. A final, quiet testament on the abyssal plain. Section 9. The Ghost Reef's Legacy. The fires have gone out. The sulfurous scent has faded from the water, replaced once again by the cold, clean, neutral taste of the abyss. The bustling, chemically powered city is a memory, its inhabitants long dead, their legacy scattered. We are now perhaps a century or more past the moment of the whale's arrival. What is left is a ghost. A ghost reef on the abyssal plain. The skeleton is no longer a recognizable form. The relentless work of the Ostax worms and the simple, crushing pressure of the deep have done their work. The great architecture has crumbled. What remains is a scattered field of bone shards, chalky fragments, and the most resilient, mineralized remnants of the vertebrae and skull. This debris field, intermingled with the countless empty shells of the clam colonies, creates a patch of hard ground, a unique texture on the otherwise uniform mud. This is the final stage of the whale fall, the reef stage. But it is a reef born of ghosts. The energy is gone. The unique chemical signature is gone. All that remains is the physical structure. And yet, even in this final, quiet phase, the whale's influence persists. It has fundamentally and permanently altered this small patch of the deep sea floor. The community that now lives here is one of quiet persistence. It is a return to the normal life of the abyss, but with a crucial advantage: the gift of substrate. The bone fragments and shells are a precious anchor. They are the foundation for a community that, while not as exotic or dense as the chemosynthetic metropolis, is still far richer than the surrounding mud desert. Slow-growing, glassy sponges take root on the larger bone fragments. These are ancient life forms, simple and patient. They filter the water with painstaking slowness, capturing the sparse marine snow that drifts down from above. Their porous, silicate bodies provide yet another layer of complex habitat, a microscopic labyrinth for tiny crustaceans and worms. Pale, ghostly sea anemones, the same species that found purchase on the fresh bones a century ago, stilled the landscape. They are tenacious survivors. Their lifespans are measured in decades, even centuries, and they are content to wait, their tentacles open for the rare, passing morsel of food. They are the patient watchers, the last living link to the reef's early days. Small, solitary corals might find a foothold. These are not the reef-building corals of the tropics, but deep, cold-water species. They grow with agonizing slowness, their stony skeletons adding, molecule by molecule, to the permanent structure of the ghost reef. Over centuries, their own remains will contribute to this island of hardness. The community is sparse, the interactions few and far between. A small fish, perhaps a type of eelpout or grenadier, might use the debris field as a landmark or a hunting ground, its sensitive barbels probing the sediment for the small worms and crustaceans that live among the fragments. A brittle star might drape its arms over a piece of the whale's jawbone, its central disc hidden in a crevice, its arms tasting the faint currents. The pace of life here is geological. Change is measured not in days or years, but in decades and centuries. The ghost reef is a slow, quiet ecosystem, a final, fading echo of the monumental event that created it. But the whale's legacy extends beyond this physical reef. The intense biological activity of the past century has left an indelible mark on the surrounding sediment. The burrowing of the enrichment opportunist worms, the accumulation of shells and waste products, the sheer concentration of life has changed the geochemistry and the physical structure of the mud itself. Even after 100 years, a core sample from this location would tell a story. It would reveal a layer rich in organic material and specific isotopes, a clear signature of the whale fall, a bookmark in the deep sea's geological history. And there is one final, profound legacy. The whale fall has been a stepping stone. For the highly specialized creatures like the Ostax worms and the chemosynthetic clams, the vast, empty plains of the abyss are an impassable desert. They cannot survive without their specific source of energy. A single whale fall, a temporary island of life, allows their populations to bloom. As the female Ostax releases her millions of larvae into the current and the clams release their own spat, they are seeding the ocean. Most of these larvae will perish, but a few, by sheer chance, might be carried by a deep, unknown current to another whale fall, perhaps 50 or 100 kilometers away. A whale that died 10 years after our own. The ghost reef, in its final act, serves as a launch pad, a reproductive node in a vast, disconnected network of deep-sea oases. The whale falls, scattered across the ocean floor like faint, distant stars, may form a chain of life, allowing these strange, specialist creatures to hopscotch across the abyss, from carcass to carcass, over evolutionary time. The whale, a creature of the sunlit surface, has become a critical link in the life cycle of the deepest, darkest inhabitants of the planet. Its death has forged a connection between two worlds that should never meet. The ghost reef will persist for centuries, perhaps even 1,000 years, a subtle anomaly on the seafloor. The bone fragments will continue to dissolve, but with agonizing slowness in the cold, high-pressure water. Eventually, even this last trace will be gone, fully integrated into the sediment. The seafloor will return to its flat, uniform state. The story will be over. But for 1,000 years, this one spot on the planet was different. It was a universe, created from a single, magnificent fall. Section 9. The Ghost Reef's Legacy. The fires have gone out. The sulfurous scent has faded from the water, replaced once again by the cold, clean, neutral taste of the abyss. The bustling, chemically powered city is a memory, its inhabitants long dead, their legacy scattered. We are now perhaps a century or more past the moment of the whale's arrival. What is left is a ghost reef on the abyssal plain. The skeleton is no longer a recognizable form. The relentless work of the Ostax worms and the simple, crushing pressure of the deep have done their work. The great architecture has crumbled. What remains is a scattered field of bone shards, chalky fragments, and the most resilient, mineralized remnants of the vertebrae and skull. This debris field, intermingled with the countless empty shells of the clam colonies, creates a patch of hard ground, a unique texture on the otherwise uniform mud. This is the final stage of the whale fall, the reef stage. But it is a reef born of ghosts. The energy is gone. The unique chemical signature is gone. All that remains is the physical structure. And yet, even in this final, quiet phase, the whale's influence persists. It has fundamentally and permanently altered this small patch of the deep sea floor. The community that now lives here is one of quiet persistence. It is a return to the normal life of the abyss, but with a crucial advantage, the gift of substrate. The bone fragments and shells are a precious anchor. They are the foundation for a community that, while not as exotic or dense as the chemosynthetic metropolis, is still far richer than the surrounding mud desert. Slow-growing, glassy sponges take root on the larger bone fragments. These are ancient life forms, simple and patient. They filter the water with painstaking slowness, capturing the sparse marine snow that drifts down from above. Their porous, silicate bodies provide yet another layer of complex habitat, a microscopic labyrinth for tiny crustaceans and worms. Pale, ghostly sea anemones, the same species that found purchase on the fresh bones a century ago, stilled the landscape. They are tenacious survivors. Their lifespans are measured in decades, even centuries, and they are content to wait, their tentacles open for the rare, passing morsel of food. They are the patient watchers, the last living link to the reef's early days. Small, solitary corals might find a foothold. These are not the reef-building corals of the tropics, but deep, cold-water species. They grow with agonizing slowness, their stony skeletons adding, molecule by molecule, to the permanent structure of the ghost reef. Over centuries, their own remains will contribute to this island of hardness. The community is sparse, the interactions few and far between. A small fish, perhaps a type of eelpout or grenadier, might use the debris field as a landmark or a hunting ground, its sensitive barbels probing the sediment for the small worms and crustaceans that live among the fragments. A brittle star might drape its arms over a piece of the whale's jawbone, its central disc hidden in a crevice, its arms tasting the faint currents. The pace of life here is geological. Change is measured not in days or years, but in decades and centuries. The ghost reef is a slow, quiet ecosystem, a final, fading echo of the monumental event that created it. But the whale's legacy extends beyond this physical reef. The intense biological activity of the past century has left an indelible mark on the surrounding sediment. The burrowing of the enrichment opportunist worms, the accumulation of shells and waste products, the sheer concentration of life has changed the geochemistry and the physical structure of the mud itself. Even after 100 years, a core sample from this location would tell a story. It would reveal a layer rich in organic material and specific isotopes, a clear signature of the whale fall, a bookmark in the deep sea's geological history. And there is one final, profound legacy. The whale fall has been a stepping stone. For the highly specialized creatures like the Ostax worms and the chemosynthetic clams, the vast, empty plains of the abyss are an impassable desert. They cannot survive without their specific source of energy. A single whale fall, a temporary island of life, allows their populations to bloom. As the female ostax releases her millions of larvae into the current, and the clams release their own spat, they are seeding the ocean. Most of these larvae will perish, but a few, by sheer chance, might be carried by a deep, unknown current to another whale fall, perhaps 50 or 100 kilometers away. A whale that died 10 years after our own. The Ghost Reef, in its final act, serves as a launch pad, a reproductive node in a vast, disconnected network of deep-sea oases. The whale falls, scattered across the ocean floor like faint, distant stars, may form a chain of life, allowing these strange, specialist creatures to hopscotch across the abyss, from carcass to carcass, over evolutionary time. The whale, a creature of the sunlit surface, has become a critical link in the life cycle of the deepest, darkest inhabitants of the planet. Its death has forged a connection between two worlds that should never meet. The Ghost Reef will persist for centuries, perhaps even 1,000 years, a subtle anomaly on the seafloor. The bone fragments will continue to dissolve, but with agonizing slowness in the cold, high-pressure water. Eventually, even this last trace will be gone, fully integrated into the sediment. The seafloor will return to its flat, uniform state. The story will be over. But for 1,000 years, this one spot on the planet was different. It was a universe, created from a single, magnificent fall. Section 10. A universe in a single fall. And so, we ascend. Let us pull our consciousness back from the silent, patient Ghost Reef. Let the scattered fragments of bone and shell shrink below us, becoming once more just a faint, pale patch on the endless tapestry of the abyssal floor. We rise, leaving the crushing pressure and the absolute cold behind, traveling back through the midnight zone, through the twilight, and towards the distant memory of the sun. Our journey to this one specific place is over, but the story it has told will echo. What have we truly witnessed in this deep, dark place? It was more than just a biological process. It was more than decay and consumption. We have witnessed a creation story. We have watched an entire universe be born, flourish, and fade, all from a single, silent fall. Consider the parallels. In the vast, cold emptiness of space, a nebula of gas and dust, the remains of ancient, exploded stars, begins to collapse under its own gravity. It condenses, concentrates, growing hotter and denser at its core until a point of critical mass is reached. Then, with a flash of fusion, a new star is born, a new sun that will power entire systems of planets, bathing them in light and energy. Now think of our whale. For 100 years, it swam in the sunlit world, a living vessel accumulating the energy of the sun. It was a nebula of life, gathering the stardust of the ocean, the krill, the plankton into one magnificent, concentrated form. Its life was a slow, gravitational collapse of energy into being. Its death, and its great descent, was the final, critical moment. As its body came to rest on the abyssal plane, it was a singularity, a point of impossible density and richness in a universe of scarcity and emptiness. This was not a death, it was the Big Bang of the whale fall, the moment of creation. The first stage, the frantic feast of the sleeper sharks and the hagfish, was the inflationary epoch of our small universe. An explosive, rapid expansion where the initial, raw energy of the whale was distributed outwards, flung into the immediate cosmos, seeding it with the potential for what was to come. The second stage, the enrichment of the sediment, was the formation of the protoplanetary disk. The rain of organic matter from the feast settled into the surrounding mud, creating a swirling, nutrient-rich cloud. In this cloud, the first simple bodies began to coalesce, the worms and the tiny crustaceans, gathering the dust of the new universe to build the first, simple structures. Then came the age of stars. The chemosynthetic bacteria, igniting the hidden fuel of sulfide within the bones, were the first suns of this dark galaxy. They did not create light, but they created life's energy, the foundation of everything to follow. And around these new suns, planetary systems formed. The clam beds and the tube worm gardens were the planets, each one a world in its own right, orbiting its bacterial star, thriving in the life-giving energy it produced. Each clam was a world, its internal bacteria a hidden sun. Each tube worm thicket was a solar system, a crimson forest warmed by an invisible fire. The whale skeleton became a galaxy, a spiral of ribs and a dense central cluster of vertebrae, each bone a star system with its own orbiting life. And through this galaxy, other life moved: the crabs and snails, like comets and asteroids, traveling between the systems, part of the great, interconnected dance. Even the Ostax worms have their cosmic parallel. They are the black holes of this universe. They emerge to consume the very stars themselves, breaking down the fundamental structure of the galaxy, returning its matter to a simpler state. They are the ultimate agents of entropy, ensuring that the cycle continues, that the matter and energy of this universe are recycled for the next. What remains, the ghost reef, is the cosmic microwave background radiation, the faint, fading echo of the Big Bang, a quiet hum of what once was, a testament to the glorious, complex universe that existed here for a time, a faint signature on the seafloor that will persist for 1,000 years. This is the profound lesson of the whale fall, that the principles of creation are universal. Whether at the scale of a galaxy or the scale of a single skeleton on the seafloor, the rules are the same. Life concentrates energy. Death redistributes it. And from that redistribution, new, more complex, and often stranger forms of life arise. The whale did not simply die. It became a founder. It became an architect. It became a chemical engine. It became a garden. Its final, silent act was its most creative. In its surrender to the abyss, it gifted a century of sunlight to the dark, and in doing so, it became an ancestor to a universe of creatures it could never have known. And this cycle is not a rare, isolated event. It is happening right now, in the silent, unseen depths of our own planet. As we rest, another great whale may be completing its final journey. Another singularity is preparing to land. Another universe is waiting to be born. The ocean floor is a star chart of these falling galaxies, a testament to the endless, beautiful, and deeply generous cycle of life and death that connects the sunlit surface to the deepest, darkest heart of our world. And so, our journey concludes. We leave the deep sea to its patient, silent cycles, to its dark gardens and its ghost reefs. We have witnessed how a single, grand ending can become 1,000 small, beautiful beginnings. The whale's great gift has been given, received, and transformed, a perfect, unbroken chain of life passing through time. As you settle into your own quiet space, carry with you this sense of profound connection. The knowledge that even in the most remote and seemingly desolate corners of our world, life finds a way to create, to flourish, and to build universes from the echoes of what came before. May the story of this gentle giant and its long, generous legacy bring you comfort. May your own rest be a moment of quiet renewal. And may your dreams be as deep and peaceful as the silent, starlit floor of the abyss. Good night.